I'm super excited to be here to talk to you about Testkube and what we've been up to when it comes to AI. So I'm going to do a couple of slides, but then I'm also going to attempt to show you kind of what we're doing and what you can do with our latest functionality if the AI gods are with me, which they are occasionally. Just for those of you who are new to Testkube, I'm going to do a little bit of a quick intro. I'm sure several of you here are familiar with Testkube, so maybe there's something new to learn from these slides. But if not, just bear with me and enjoy the ride until we get to the AI stuff. Just at a high level, what is Testkube? It's a cloud-native continuous testing platform, which provides you with a test workflow catalog for cataloging all the tests that you have in your infrastructure, in your Git repositories, and wherever they might be. It has an execution engine that can run those tests at scale inside your infrastructure using functionality provided by Kubernetes. On top of that, it then layers test observability, meaning it's really great at collecting logs, artifacts, anything resource metrics, anything produced by the tests while they're running. And then there's a nice analytics portal at the end that kind of helps you do some high level charting and stuff like that. And this then can, of course, be applied to all the pipelines that you have, all the environments that you might be running tests in, all the testing tools that you're using, and all the ways you're running your tests. So it's really that one-stop shop for all tests that you're doing in your infrastructure. The core tenets of Testkube are that it's vendor agnostic, means that it'll work with any tests that you have today, any testing tools that you have today. So if you're using Playwright, K6, Postman, Cypress, JMeter, Selenium, and others, or your own scripts, anything that can be packaged in a Docker container can be orchestrated and managed by Testkube. It'll integrate, of course, with your CI/CD tools. So if you're doing Jenkins, GitHub, GitLab, CircleCI, or if you're doing Flux or Argo CD, or if you're using Tekton or whatever you might be using, you can, of course, integrate those with Testkube to run tests. And then you can, after you've run your tests, you might want to integrate with tools like issue trackers, like test management tools. You might want to push results to data collection tools like Datadog, or collaboration tools you might want to notify on Slack, etc. So it does all of that. So it's really that thing in the middle that's really just focused on running tests as better than anyone. To do that, Testkube introduces the concept of test workflows, which is something that we've purpose-built for running tests at scale. Test workflows is our YAML syntax, because that's what companies have nowadays, for defining how to run a test. And we've built that syntax or vocabulary specifically with test execution in mind. So it really caters to parallelization, sharding, matrices, spinning up dependent services, running tests in parallel or in sequence. All of those things are things that are first level items or objects in that vocabulary. So it's really geared at running tests and not other things that you might want to do with a workflow engine. And then we've implemented that in workflow engine on top of Kubernetes, which means that we can leverage Kubernetes for a lot of the those function features that I mentioned, so parallelization and sharding, etc. We can kind of do that on top of what Kubernetes provides, which is a great match. It's very developer-centric, we'd like to think at least. It has a CLI, it has a REST API. It's very close to Kubernetes in many ways, and now it also has an MCP server, which we're going to talk about a little bit later. It's cloud-native in the sense that it leverages Kubernetes native constructs for a lot of things that it does. As I said, it's running on Kubernetes. It's using CRDs to define all its core resources. So you can manage those CRDs through GitOps workflows in your Git repositories and kind of align with how you might be doing GitOps otherwise. It also hooks into Kubernetes events for triggering test execution. So if you want to run tests based on changes in your infrastructure, you can set that up within Testkube without having to use any third-party tools. And it kind of embraces cloud-native application and infrastructure patterns, meaning that it's really built to work and be integrated into the pipelines and the workflows that people are building on top of cloud-native technologies. It solves a lot of problems, at least that's what we'd like to think, related to test sprawl. If you have tests sprawled across multiple teams, tools, components, CI/CD pipelines, It helps with CI/CD bottlenecks where CI/CD tools are not always great at scaling out your tests. It helps just with if you have a fragmented infrastructure environments, if you have lack of test observability, as I mentioned. Testkube is great at collecting results for your test executions, which can be hard if your tests are running in a very distributed environment, and especially collecting them in a way that's helpful for dev and QA engineers and not ops people, but the people who are the one tasked with troubleshooting failed tests. It's also, since it's running in your own infrastructure, and once again on Kubernetes, it's very resource non-intensive. Testkube in itself consumes very little resources. What really consumes resources is the actual test execution, but when no tests are running, no resources are consumed. And it's for dev teams, quality engineers, DevOps, SRE. It kind of helps everyone. Everyone is touched by testing. Ops teams are the ones tasked with setting up tests and build pipelines. Dev and QA teams obviously work with tests. Platform engineers might be provisioning scaffolds for testing, and Testkube kind of works across all of those roles. It helps everyone align on testing and hopefully make that more efficient. It's great, in other words. At a high level, architecturally, not going to go too deep on architecture, Testkube has an agent that you deploy in the clusters where you want to run your tests. And this agent is open source. It can be run standalone without anything else around it, and you can run multiple agents standalone as you want. And if you want to manage multiple agents, you can connect those to a control plane, which is our commercial offering. The control plane adds a bunch of test orchestration capabilities on top of the singular agent, allowing you to run tests across multiple agents and orchestrate that. It also adds functionality for SSO and integrating with SCIM servers and working with insights and status pages and scheduling and a bunch of things that maybe appeal more to teams or larger organizations adopting Testkube and wanting to get on top of their testing workflows and pipelines. But the agent itself is a very common starting point, and super excited to see people using that and then growing into the control plane. Okay, so that was kind of a very quick intro on Testkube. If you want to know more about Testkube, go to our website. So what if Testkube, or what if when you run your tests and they fail, you could automatically get a pull request created for you with a suggested fix for that reason for failure? Or what if only the tests that are required for the fixes or changes you've made to your infrastructure are run for every commit or pull request instead of all your tests? Or what if your load tests could automatically configure themselves based on instructions from you of how many transactions per second they should be creating? Or what if your ops team is proactively alerted of test executions that are behaving weirdly, kind of taking more time, consuming more resources, something that you might not notice on the test execution or functional side, but on the operational side? And in that case, maybe even that team is presented with a fix or a suggested fix. And these are kind of scenarios along the entire pipeline. And I'm sure we can think of more scenarios where having an agent or some kind of hand-holding to proactively help you with these things would be helpful. So, and that's what we also think is a great future direction for Testkube to kind of head into. So I'm going to talk a little bit about that. I'm going to try to show you at least some of those use cases. And as before, if there are questions, etc., please pop them in the chat. So Testkube has actually had AI functionality for quite some time. What we introduced an AI assistant in the product, which is hard to see. It's down here to the left in the dashboard, where you can prompt around analyzing test results. You can create, modify your workflows. It'll help you navigate and understand the product. And this AI assistant is good, but it also has its limitations. It uses the LLM that you've configured. So if you have internal LLMs, you can use those. Otherwise, it'll use a public LLM where you have to have an account. But what we've ventured into now, and we're not the only ones, of course, in the space, is to looking at MCP, which is a reasonably new technology, and launching an MCP server for Testkube, which we did a couple of weeks ago in its initial iteration. And what that allows you to do is to integrate Testkube into your AI agents and tools and workflows for much more complex scenarios. And it'll also is very, once again, developer focused. And I'll show this in just a little bit if the AI gods are with me. So what is an MCP server? You might want to know. MCP is a standard model context protocol. There's a link here at the bottom. You can navigate there. Let me see, I'm going to hide this thing here. Go there and read more about it. Basically, MCP servers are like a bridge between files or data sources or services, APIs that allow MCP hosts to consume those data sources in a way that make them usable for an LLM. So if you're using an IDE or a Claude, or you're building agents, those can use an MCP server then to interact with external systems and bring functionality and data into those workflows. And if you're into AI, I'm sure you're very familiar with this. It's a concept that's been very, very popular over the last months. So the Testkube MCP server, which you can then now use to interact with Testkube in this way that I explained, exposes a number of core tools to LLMs. So what that means is that through the MCP server, you can create and run workflows, you can analyze existing workflows and their executions, you can get logs and artifacts, and you can navigate to the dashboard. If you're familiar with how MCP servers are configured, you'll recognize this. These are the kind of underlying operations that we currently expose. This is something we're going to expand on over the coming weeks and months when we learn more about use cases. Basic use cases is that this is almost like a CLI, an intelligent replacement for working with the Testkube CLI. But you can also do some pretty advanced result analysis since you can pull logs and have the LLMs analyze those logs, which can give some interesting results. But I think where it becomes really interesting is when you combine the Testkube MCP server with other MCP servers. So for example, the Kubernetes MCP server for more advanced troubleshooting, right? So why did this test fail? The LLM can both look at the artifacts and data retrieved from Testkube, but it can also go out to Kubernetes itself and maybe try to collect some data from there. Or if you're looking at remediation, if you want to create a pull request, as we talked about earlier, that fixes a failure identified by a test, an agent or a prompt could automatically do that for you in the best of worlds. But I'm sure there's a lot of MCP servers out there, and you can imagine kind of the kind of natural language or the functionality you can build on top of those and related to testing, with Testkube being one of the key pieces there. And I think what's interesting here is that Testkube is, as far as we know, the only test-oriented MCP server out there that allows you to interact with test results and test executions in a test-centric way versus seeing tests as just another build step. Testkube has a very testing-focused view of the world, not surprisingly. Okay, how do you get started? Before I jump into the demo, so you sign up to the control plane. If you don't have it already, you create an environment, you install the agent, so you're up and running with Testkube, and then you install the Testkube CLI, which you can, on Mac, you could do brew install Testkube, and then you log in to the control plane. And this is really important because this is going to set the context for how, under which the MCP server operates, meaning that if you're logged in as a user with certain access rights permissions, the MCP server will have to honor those, right? So you can't use the MCP server to bypass permissions that are set on your user account. And then finally, you have to configure your IDE to use the MCP server exposed by our CLI. So those of you in the know will maybe ask, so this is a local MCP server, and do we have a remote or hosted MCP server? And that's something in the works. For now, you have to be running the CLI locally for getting access to the MCP server. And we have examples for VS Code, Cursor, Claude, Desktop in our documentation, so you can head over there if you're curious on how that works. Okie dokie. Let's see. Okay, let's give it a try. I'm going to try to do a lot of things that I talked about here. As before, somewhat of a disclaimer, especially when working with AI. You never know what's going to happen, but it's gone pretty well when I've been rehearsing for this webinar. So let's see if the AI will play with us, play with me here. I'm going to try to show just some basic use cases, the AI assisted remediation, and some adaptive performance testing. But if there are things you'd like me to try, if you're familiar with Testkube or just curious what it can do, put those in the chat and I'll see what I can do. We were a little bit short on time, but if I won't be able to do them now, it's something that would be a great follow-up blog post from us, for example, where we show some of those things. And I don't have a really good concept of time. It's 20 minutes. Okay, cool. Let's see if we get any hallucinations. So first of all, I'm going to be using Cursor for my IDE. Cursor is based on VS Code. So if you're familiar with VS Code, you'll feel this is very, you'll recognize yourself. In the Cursor configuration, you can see that I've configured the Testkube MCP server. And you can even go and look here at what the actual configuration looks like. If that's kind of interesting. But this is kind of the configuration you have to set. And here you can also see the tools that Testkube exposes. So this is all set to go, hopefully. So let's close that. I'm also going to be, on the flip side of this, have a Testkube environment up and running here. This is running in my local kind. The agent's running in my local kind cluster. I have a couple of workflows that I'm going to be interacting with through the MCP server. So let's see how that works out. Let's go over here again. Hey there. Hello. Show me my workflows. Okay. So this is just a very simple prompt. As you can see now, I asked it what workflows do I have. It's going to give me a list of those workflows. Okay. Give me a summary of the last 5 executions. Let me see. Let's take one of these. The K6 sample. So here it's going to be looking at those results and pulling them for me immediately here. So let's do some little bit more advanced querying. If you're familiar with how these tests work in Testkube, let's look at the K6 sample here. The latest executions, this one didn't actually run. It did create an HTML report. I'm actually going to look at another one here, which is the distributed example, because this has been running across multiple workers. So it's a distributed test. Let's look at the distributed example. Oops. Instead, give me aggregate performance metrics for all nodes for its last execution. Let's see what happens here. Okay, so it's giving me kind of high level breakdowns of that. Okay, but what I wanted to do is that each of those nodes has its own log. If we go back here and look at that execution, you can see the different workers here. You can see this is the output of each node. What I wanted to do is kind of create a summary of the performance metrics that I got across all those nodes. So let's try that. Aggregate TPS and average response times across nodes execution. So now it's reading, it's read all the logs from those 3 nodes. and now it's actually doing a combined analysis of the response I got here. So this is a really powerful way to kind of work with more advanced results. And what I could do now is I could ask it, okay, I'm not going to do it because it'll take a little time. Let's compare these results to previous executions of this load test. Or if I ran this load test on a different agent, let's say I ran the load test on 2 agents. I want to compare the aggregate results from the different agents. And it'll actually do that really nicely, and it can create like spreadsheets for you, etc. Some of you might be asking, how do we know these numbers are right? And I asked myself that the first time I did this, and I manually then went into each of the logs and extracted the numbers and had my calculator up and ready. And at least at that scenario, everything was correct. But it's of course a good practice to sometimes maybe double check just to make sure that you're actually getting the results you want. I don't know if there's anything else I want to try here. Hopefully you get the idea. You could be here interacting with, let's say, if your test generates an HTML report, maybe you want to analyze that. Actually, that K6 sample test did that. Break down the HTML report. Oops, sorry. Report generated by that latest K6 sample execution. Let's see if it. So now it's interacting with Testkube, it's retrieving the artifacts, and let's see if it. Okay. Well, it was actually able to do something with this. Once again, I could ask it to summarize this in different ways, etc. But just once again, to give you an idea, it's pretty capable of understanding what you want it to do and interacting with Testkube to retrieve objects or things that you might be interested in. Okay, so that was the first use case I want to show you. The next one, which is maybe more intriguing, is let's go back to the slides, is an AI-assisted remediation. So this is where in your IDE, which I'm going to do, is you run a test and against the system under test. And then if that test fails, you'd want the IDE to be able to look at the test results and at the code that you have and somehow maybe figure out why the test failed. And in a perfect world, also generate a pull request for you, or at least a suggested change. So let's attempt that. Obviously, I've prepared for the webinar, and it usually works, but you never know. So let's go back to cursor here. I'm going to switch to another project. And here we're also going to enable the GitHub MCP server. So that's running now. And let me see. The project is the project that I'm going to explain the setup here. So I have a local, as you know, I have the local kind cluster. I have a local service deployed. The service is a simple calculator. The actual source code for that is here. I suspect there's a bug in there. I will find out soon. I also have a test in my, here we go, the calculator addition test that I'm going to use to, I'm going to run that against my locally deployed application. So let's do that first of all. Run the calculator test or workflow. Results. So it's running the test now. We can go, well, it's already finished. Okay, there's a lot going on here. Okay, so it ran the test, so we can go in here and look at the actual execution. You can see that it actually ran the test here. This is a Postman collection. We can also look at the results. And as expected for the demo, the test failed. So let's have a look at if we can get the get it to suggest a fix. Okay, can you find the cause for this failure in my project? Yay. So it's kind of calling me out here that I placed an intentional bug in the code for demonstration purposes, but it did find that for me. Yes, please. I want it to fix the bug for me. And I'm always polite with these AIs. I think please is important. Okay. So now it's applied that fix. Okay. Let's also ask it to create a pull request for the fix. Let's see if this works. It's going to ask me to, it wants to run some Git commands. So it can kind of check the status of the project. Now it's pushed something. Let's see if it's done what I want it to do. Oh no, let me see. Let me see. Looks like this is not working, unfortunately, but you get the idea. Ultimately, it should have been able to, oh, let me see, changes committed and pushed. The fix is ready and changes pushed to GitHub. You can create the pull request using the link above. Really? Okay, I don't have a link here, but let's just have a look at the repo. There were pushes here, compare pull request. Oh, look, it actually did fix the bug. It also pushed the update to the Postman collection. Interesting. Anyway, but as you saw here, it was actually able to, I mean, this is obviously an extremely simplistic example, but it was able to fix the bug, which I kind of pointed out in the source code where it was. So that's kind of cheating, even for an AI. And then it was able to create the pull request to do all that stuff. And of course, I did this manually, but this could be packaged in an agent or could attempt to package this in agent. I'm not going to do that on the demo, which does all of these things for you, which would be triggered by a test failing in Testkube. So which would then look at the source code, try to identify the error. If it does, create a pull request, post a link to that pull request on Slack, for example, and then someone could look at that to see if it's correct or if it should be merged. Great. Okay, so that was that use case. And the last one was, I was going to go back to the load testing one, actually. Let's jump back here. And let's also just turn off the GitHub. Oh, this is disabled here. Okay, great. Okay, so this was the distributed example where it, okay, now, okay, let's continue here and say, ramp up my distributed test to generate 500 TPS. Let's see what happens. So now it's doing a bunch of analysis. And this is kind of where the prompting is super important. I'm pretty sure I didn't do the exact prompt that I did earlier today when it worked, because now it's kind of going off in different directions. But if you get the prompts right and it has the right context, it should be able to, in this case, look at the previous executions, based on that, calculate how to ramp up or increase the load in the K6 load test here, and then run the test and then validate that it actually, look at the results once again, validate. Let me see. no, this web search is not going to go anywhere. Let's stop there. Just run the distributed K6 test with default parameters. Okay, so we can look over here in Testkube that it's running here now. And that's gonna take a little while. This is running across 3 worker nodes and it's generating some load. Okay, let's see here. Wait for it to finish. Then give me a high level results. Oops. Okay, so this is similar to what we did before. So the TPS here was, if you saw, 612. Let's see if it's able to ramp up this test to create, sorry, to generate 1,000 TPS. Oh, here it actually created a new workflow for us. That's interesting. So let's look at Testkube. So we'll see that it's actually created a new workflow, which is not what I was expecting. And now that workflow is running. Okay. Oh, it chose to use 5 worker nodes. Ask how's it going. Okay, now it's going to get the logs from each of those nodes. As you see, we have 5. Okay, and what did we get? Ah, nice. So we actually made 1,100 TPS. So it was it solved the problem, not in the way I expected it to, because the K6 workflow that I have is configurable. So you can provide parameters to it, to how many nodes it generated, but that's not something the LLM was aware of. So instead, it created a new workflow on its own that had the right configuration to generate a little bit over 1,000 TPS, which is actually very, very creative result. I'm impressed. Okay, great. I think that's all for the demo. And time is flying. So some learnings here, I guess, as you saw, getting the prompt right is key. So you have to play around with this a little bit. And then now I'm not sure which LLM it's using by default, but I'm guessing if you switch to GPT-5 or something else, which I know I'm not using, the results, you might have to adjust your prompts accordingly. So that's why prompting is super important, and finding the right prompts. But it's also, as you saw, it didn't do what I expected it to, and that could also be blamed on our MCP server, because the MCP server exposes metadata on what operations it has and kind of how those are meant to be used. So maybe we're just missing something there, which was the reason for the LLM not choosing the best path. I think the MCP interface and this kind of chat interface is actually great for kind of exploratory, especially load testing like this. So like I said, if run this on if you have multiple agents, you can ask it to run on all the agents and compare the results and create a chart for me and all that kind of stuff. So it's really natural interface for doing that. And often it goes further than you expect when it comes to problem solving. We didn't have, we didn't have any hallucinations as far as I know. I didn't validate the results. But if you're generating code fixes, obviously you have to review them. I wouldn't, don't blindly trust what an AI generates for you. You can also try different models, just as I was alluding to. This, I don't know if this is using Claude Sonnet or something, but there are maybe the model for the things that you want to do, you don't need to use the most expensive model, and that could be a way of optimizing. And finally, I'll say this is somewhat non-deterministic, which can make a demo hard, meaning that just because it gives you one answer earlier during the day doesn't mean it gives you the same answer later on, but it's usually in the right ballpark. And it definitely gave me the answers here that I was hoping for. So what's next for Testkube AI? As we're obviously early in our AI journey, but we see so much potential. And as you can see here, this is just there's just so much that could be done with this. And so what we want to do is the AI assistant in Testkube itself to be able to consume MCP servers. So users don't have to leave Testkube to be able to do the kind of things that I just did. We want to further package those prompts into kind of agents, so that you can in Testkube say, when a test fails, run this pipeline script, whatever we want to call it, and try to remediate that, like I did here. Or when a change happens in GitHub, look at the changes and decide which workflows to run, or like the other use cases I had earlier. So there's a lot we could do just because Testkube has this unique context of the tests that you have, the infrastructure you have, and the test results you have since previously. And that combined with MCP servers for other tools, put it in a unique position to help with test-related activities. But ultimately, also, we want to learn from you watching this. And so, because it's very use case driven, and the use case I showed was something we got from one of our customers. This is what we'd like to be able to do with your MCP server, and I hope you guys are watching. Otherwise, we'll send you the recording. But this is, if you kind of feel, it would make so much sense to be able to do this or that, please reach out to us on Slack or whatever channel is best for you. And with those rapidly spoken words, I will thank you for joining. Questions, get in touch. I'm sure there will be, let's go to the questions. You can go to getting started with the MCP server. Just go to our docs, testkube.io/MCP, docs testkube.io for AI, open source, Slack, website, LinkedIn. I'm sure
we do have one question I'd love to just finish on. Add it to the stage here. Oh, it is too big. I'm going to remove it from the stage.
Oh, here we go.
Okay. Okay, so the question is, with AI maturing day by day, how confident are we from MCP perspective on solving the test automation challenges using Playwright? I'm sure that MCP is still not fully matured enough. What's our outlook on the MCP?
So I need to read that question again. Is it in the question?
It's in the Q&A. I made it.
Oh, there we go. Great question. Let me just reread it once. I think, so great question. I think the MCP server for Playwright specifically, so MCP as a standard, you're totally right, is still pretty new, and there's definitely in ways it can evolve and mature. I think the MCP server Playwright specifically is geared at helping you automate Playwright interactions through prompts, like basically what I did here in Cursor. I could have interacted with the MCP Playwright server to perform tasks on their website, test-related tasks. And I'm guessing that they are in a similar position as we. It's very use case driven. Obviously, they have a slightly larger audience than we do. So I'm sure they've come farther ahead when it comes to gathering input and adapting their MCP server to really support the use cases that users are asking for. So I mean, the outlook is positive. I'm almost always positive when it comes to outlooks. So, but it's a very fast-moving space, and I think, as with any product that you're using, giving feedback to the people creating them is super helpful. Just making, helping them shape the direction of their tool. Hope that answers your question.
Awesome. Thank you so much, everyone, for watching. We're at time. We will be sending a recording, and we'll have this submitted on YouTube as well. If there are any direct questions, as Ule said, you can reach out to us directly or even contact Ule at testkube.io. And we're really happy to have gone through this demo with you all. Have a good one.
Thank you. Bye-bye.